Fizz Buzz is often introduced as a beginner-level programming problem, but it is actually a very effective exercise for learning how to structure conditional logic clearly and correctly. Rather than rushing straight into writing code, it is worth taking the time to understand the reasoning process that leads to a clean and reliable solution. Before we continue, a quick note about the channel membership. If you're watching without a membership, you currently have access to easy-level problems only. To unlock medium and hard problems, you'll need to join one of the memberships. Most people choose one of these two tiers. The first one is the first-time offer for Ninja. It's just 90 yen, and it's designed for first-time subscribers. You get access to all medium and above videos, completely ad-free. If you want to try the full content with minimal commitment, this is the easiest way to start. The second popular option is Buy Me a Coffee. This tier is not just about algorithms. You also get content on databases, networking, and servers, the infrastructure topics that real software engineers use every day. On top of that, you can request any LeetCode problem you want me to solve. Your questions get noticed and answered much faster. And of course, you still get access to all medium and above videos, completely ad-free. If you want to level up not only as a problem solver, but as a well-rounded engineer, the membership is the fastest way to do that. And it directly supports this channel. Alright, let's get back to the problem. The problem itself is simple. We are given an integer n, and for every number from 1 to n, we must generate a string according to a fixed set of rules. If a number is divisible by both 3 and 5, we return Fizz Buzz. If it is divisible by 3, we return Fizz. If it is divisible by 5, we return Buzz. If none of these conditions apply, we return the number itself, converted to a string. All of these results must be returned as a list, in order. The first thing to notice is that every number from 1 to n must be processed exactly once. This immediately suggests the overall structure of the solution. We need a loop that runs from 1 to n, a list to store the results, and conditional logic inside the loop to decide which string to append for each number. At this stage, the exact syntax does not matter. What matters is understanding the shape of the solution. The most important insight in this problem is that the order of the conditions matters. The challenge is not checking divisibility itself, but handling overlapping conditions correctly. Consider the number 15. It is divisible by 3, and it is also divisible by 5. If we check for divisibility by 3 first, the program would incorrectly return Fizz instead of Fizz Buzz. This leads to a fundamental rule when writing conditional logic: always check the most restrictive condition first. In this case, the condition, divisible by both 3 and 5 inches, must be evaluated before the individual checks. There are two common ways to express the condition, divisible by both 3 and 5. One is to explicitly check both conditions using i%3 == 0 and i%5 == 0. The other is to take advantage of the fact that the least common multiple of 3 and 5 is 15, and simply check i%15 == 0. Using 15 is concise, readable, and mathematically clear, which makes it a good choice here. This becomes the first condition in the loop, where we append Fizz Buzz to the result list. Once this most specific case is handled, the remaining logic becomes straightforward. If the number is divisible by 3, we append Fizz. If it is divisible by 5, we append Buzz. Finally, if none of the conditions match, we append the number itself after converting it to a string. This conversion is important because the problem explicitly requires the output to be a list of strings. Putting all of these ideas together results in a simple and readable implementation. We initialize an empty list, loop from 1 to n, check divisibility by 15 first, then by 3, then by 5, and fall back to the default case when none apply. After the loop finishes, we return the list. Although Fizz Buzz is a simple problem, it reinforces several essential programming fundamentals. It teaches us to iterate over data exactly once, to design clean and predictable conditional logic, and to carefully order conditions when multiple rules can overlap. These principles extend far beyond this problem and appear again and again in more complex algorithms and real-world code.
Okay, let's write the code. First of all, create a result variable. This is array. And then let's iterate through from 1 to n. So for I in range, start from 1 to n. So we have to add +1. And then if I divide 15 equal 0. So 15 is the least common multiple of 3 and 5. And then in the case, let's dot append. And in this case, append Fizz Buzz. So Fizz Buzz. And else if I divide 3 equal 0. In the case, let's dot append. And in this case, I think Fizz. Else if I divide 5 equal 0. In the case, let's dot append. And in this case, Buzz. If not the case, else, let's dot append. And we need to convert integer into string, like string and I, like this. And then after that, just return less. Yeah, so let me submit it. Yeah, looks good. And the time complexity of this solution should be order of n, and the space is O1, except this result variable. Yeah, so that's all I have for you today. Please support me with the actions such as comment and hitting like button. I'll see you in the next question.